Hi everyone, this video is pre-calculus section 11.3, so the second half of section 11.3. And so I'm starting with example 5. So in the previous examples for 11.3, you learned that limit definition of a derivative, so I'll just rewrite that, which says if you take the limit as h approaches 0 of f of x plus h minus f of x over h, that's going to approximate the slope of the tangent line at a specific point, or it is also called the limit definition of the slope of the graph. I think that's probably in your student note packet. So all that this means is you're taking your function here, x squared plus 1, and to do this part of the limit, we are replacing the x with x plus h, and then we have to do some simplifying on that. And then this part of the limit is just x squared plus 1. That's just your f of x. And then that's h. And then it says, what are the slopes at these different points? So we're going to first find the slope using this. So I find it helpful to first find the pieces before you plug it into the limit. So by the pieces, I mean, let's find f of x plus h. So if I go to my function and I replace x with x plus h, I get x plus h squared plus 1. Now x plus h squared is the same as x plus h times x plus h plus 1. And then if you do FOIL or box, whatever you're going to do on that, you're going to get x squared plus 2xh plus h squared, and then there's my plus 1. So all of that is f of x plus h. So that's going to go right here into my limit. And then f of x is just x squared plus 1. So now I'm going to go back up here and I'm going to say, okay, now I'm continuing with my limit here and I'm plugging in the pieces. So I have not taken the limit yet. So I have to write the limit as h approaches 0. F of x plus h is all of this. So I'm going to have x squared plus 2xh plus h squared plus 1 on the top there. Remember, this is a fraction. I'm just going to have h on the bottom, so I'll go ahead and write that. And then I'm minusing, so it's important that you use parentheses here because we're going to distribute that negative. So minus f of x is going to be minus x squared plus 1. Okay, I'm going to do a little dividing line here. So I have not taken the limit yet. So again, I have to write the limit as h approaches 0. And now I'm going to distribute that negative or multiply by negative 1. So I'm going to have x squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. And then at that step, some like terms will combine to 0. So negative x squared and positive x squared, that is 0. And negative 1 and positive 1 is 0. So the terms that I'm left with after this step should both contain h's. So now this is what I have. 2xh plus h squared over h. Now there's two ways to think about this next step. You could think, oh, I'm going to factor that numerator because I notice it has a common factor of an h. So if I factor out an h, I would get, if I factor an h out of this term, I'm left with 2x. If I factor 1h out of this term, I'm left with 1h. And then, do the check where you distribute to see if you factored right. So this would get me 2xh and h squared. So I factored right. And now you can see h divided by h is 1, so those h's 1 out. So now I'll write the limit one more time. I have this. Now I can take the limit using substitution. So if I substitute a 0 in for h, my limit equals 2x. So notice I kept writing that limit. This documentation is important until I actually take the limit, till I did the substitution and took the limit. Okay, so I have 2x. So that is the slope of the tangent line at any point, slope of tangent line, which is derivative. Okay, now what it asked for, it says, what are the slopes at the points x equals -1, 2, and x equals 2, 5. If you didn't get a chance to write that whole problem out, then I would say pause the video and write that out. So now I'm going to say at the point -1, 2, my slope would equal 2x, or 2 times -1, which is -2. And at the point 2, 5, my slope is 2x, so if x is 2, I'd have 2 times 2, I would have 4. So if you think, you know what that graph looks like, that's a parabola, x squared shifted up 1. So when x is -1, which I'm going to say roughly is over there, if I draw a tangent line, it should have a negative slope, and I did get a slope of -2 when x is 1. And then if this is x is 4, should make my parabola go a little higher. So that would be somewhere up here. If I draw a tangent line, that's a pretty steep positive slope. So it makes sense that I got a slope of 4 over there, and that I got a slope of -2 there. Okay, the next problem is a your turn. So you should pause the video and write this problem down. And then I can tell you for your slope, you should get 4x. And at these 2 points, you should get a slope of -12 and 8. So those are your answers. Definitely try that though. Use proper limit documentation throughout. Okay. So derivative of a function, I think I have already started calling this the derivative, which actually maybe technically I shouldn't, because here we have, and this is in your student note packet. So let's consider this function that we already did and use the limit process to derive the slope. So we use that limit definition of a derivative to find out the slope. That represents the slope of the graph of f at any x value. This derived function, so what they're saying is this slope is a function, and the original function that you started with is also a function. Is called the derivative of f at x. It is denoted as f, we call that prime of x. So it looks like a little apostrophe. So that means the derivative of the function f of x. Yes. Sorry about that. So definition of derivative. The derivative of a function f at x is given by, here's that documentation, f prime of x equals that limit, providing the limit exists. So that is what I frequently refer to as the limit definition of a derivative. And again, a derivative is the slope of the tangent line. So this helps you figure out what the slope of the tangent line is. All right. The derivative of a function. So this next example says, remember that the derivative f prime of x is a formula for the slope of the tangent line of f at point x f of x. So it's just reminding you, this is reminding you that derivative is slope of the tangent line. So now you could say derivative is slope of tangent line denoted as f prime of x, and it can be found by taking the limit as h approaches 0 of f of x plus h minus f of x over h. So it kind of brings all of that together. So pause the video, make sure you have that in your notes, and then we're going to go on to example 6, which looks like a long one. So get ready to do some writing. So find the derivative of this function. So again, we're using this limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so I like to do it in pieces. I might switch to pen here so you can see this easier. So first I'm going to find f of x plus h. So in here, I'm going to throw out that x and replace it with an x plus h, and I'm going to throw out that x and replace it with an x plus h, and then I'm going to simplify it. So I like to simplify before I plug it into the limit. So it's going to look like this. 3x plus h squared minus 2x plus h. So keep that 3 out in front, and remember this is x plus h times x plus h. We've done this a few times now, so I think I'm going to go right to x squared plus 2xh plus h squared. So that's when you multiply x plus h times x plus h. And then this would be minus 2x minus 2h. Now let's distribute that 3. So 3x squared plus 6xh plus 3h squared minus 2x minus 2h. And then I really don't see any like terms that I can combine. Okay, so this is what I'm going to plug into my limit function. That is f of x plus h. And then let's just remember f of x is just going to be 3x squared minus 2x. Okay, now let's put it all into our limit. So we're taking the limit as h approaches 0 of f of x plus h, so all of this, 3x squared plus 6xh plus 3h squared minus 2x minus 2h minus f of x. So I'm doing those parentheses because I need to distribute that negative. All over h. Keep going with your algebra here, limit as h approaches 0. Yes, I do have to copy all that again. Minus 2x minus 2h minus 3x squared plus 2x. Now this is the step where some things should add to 0 when you combine like terms. And all the terms that you're left with should have h's in them. So I got a positive 3x squared and a negative 3x squared. So that is gone. A negative 2x and a positive 2x. And then do that little check. Does every term that I have left have an h in it? Yes. So I did that correctly. So now I have 6xh plus 3h squared minus 2h all over h. So in the last example, I factored out an h, but you can also think this is a common denominator over all of these terms. So you're dividing this first term, 6xh, you're dividing that by h. You're dividing this second term by h, and you're dividing this term by h. So if I divide h into this first term, then that would be gone, right? H divided by h, that would be a 1. If I divide h into here, well, I have two h's on the top and one h on the bottom, so I would just have an h to the 1. And then if I divide an h into here, h divided by h would be 1. So now what I have is the limit as h approaches 0 of 6x plus 3h minus 2. Okay, now I'm actually going to take the limit. So I'm going to substitute in 0 for h, and I would get 6x plus 3 times 0 minus 2, which is 6x minus 2. So, whoop, you can't see that. There we go. Let me zoom out a little here. So that is my derivative. So notice you have to write this limit all the way until this step when I actually took a limit and then I used an equal sign. In between these steps, I recommend just putting an arrow. And then when you're actually taking the limit, use your equal sign. So this represents f prime of x, 6x minus 2. So the derivative is denoted by f prime of x. So label that as f prime of x is 6x minus 2. All right, if you need to, rewind, pause the video, make sure you get all this in your notes though. That is the solution for example 6, which we don't need. So then we're ending this with a your turn. So again, you're using the limit definition to find the derivative of this, and I will give you the answer. That is what you should get after you take your limit, and then that is the derivative of f. So label that as f prime of x. Okay, that ends this video for section 11.3.